Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 12.5, Permutations and Combinations. We are on Part 3, and we're going to talk about combinations. And combinations are different than permutations. In permutations, if you recall, the order did matter. Well, in combinations, the order does not matter. So the combinations of two letters from the word July, we could have different ways of expressing that. We could have JU, and then JL, and we could have JY, we could have UL, UY, or LY. Doesn't really matter. So there's 6 different ways. What about the combinations of all the letters in the word July? Well, there's only one way. It doesn't matter which way that you get the letters, as long as you get all 4 letters. So there's only one way to do that. Just J, U, L, and Y in any order that you want. So the combinations has a formula, and the formula works out like this. If I have a number of combinations of n objects taken r at a time, then I have n objects, choose r. It's going to be n factorial over r factorial times n minus r factorial. Looks a lot like the permutations formula, except that it's got this extra r factorial. So the combinations of 2 letters in the word July, that's going to be, we have 4 letters to choose from and 2 that we're going to choose. So it's going to be 4 factorial over 2 factorial times 4 minus 2 factorial. And when we work that out, we have 4 times 3 times 2 times 1 over, well, 2 factorial is 2 times 1. And then we have 2 factorial, which is 2 times 1. And these 2 cross out that 4, cancel out. So then we end up with 6 different ways, which is what we had predicted before. What if we have 4 and we're choosing all 4? Well, that's 4 factorial over 4 factorial, 4 minus 4 factorial, which this 4, those cross out, and this one turns into a 1. This 4 minus 4 is a 0 factorial, which is a 1. So then there's one way that you could choose the letters in July. Now let's take a look at this problem with a sandwich at a restaurant, and we're choosing 2 sides. So the sides are over here, and we have 8 of them that we could choose from. How many different ways can we choose 2 side dishes of 8 when it really doesn't matter which order that I get the side dishes as long as I get the 2 that I want? So that's going to be combinations of 8, choose 2. And the formula says that's going to be 8 factorial over 2 factorial times 8 minus 2 factorial. And that equals 8 times 7 times 6 factorial over 2 times 1, and this is 6 factorial, and the 6 factorials cancel out. The 2 cancels into the 8 and makes it a 4. So we have 4 times 7, or there are 28 ways that we could have our side dishes, or 28 different side dish combinations. So that ends it for this part of Chapter 12.5, and we'll discuss more of this in class tomorrow.